Variance and standard deviation are a measure of the spread of data. And so we're going to look now at what these are and how to find them. So we've got a set of data here as an example. And if we picture them spread out on a number line, this is what they'll look like. And we can, just by looking at them, we can get a sense of how spread out they are. And one measure that you know about how to find a spread of data, how to measure it, is the range. And you know that we find the range by finding the difference between the highest and the lowest values. Now, what this does is it tells us the difference between the extreme values, but it doesn't tell us how spread out the other values are within that range. The standard deviation gives us a kind of average deviation from the mean. The values we've looked at on the number line, you can see on the diagram there what the average is, what the mean is. And these arrows are showing the deviation of each data point from that mean. If we wanted to just find an average of those distances from the mean, and we took the values above the mean as positive and below the mean as negative, when we found their sum, we'd find that it equals 0, and that's always the case. So to avoid that, we square each deviation and then sum these squares. So for our data values, there's the sum of our squares. We find an average of these square values using this formula, the sum of the squares divided by the number of data values. And there's our value for our set of data, and this is the variance. So here we've got a couple of formulae to find the variance. This first one is the one that we've been using, where we find the difference between each data value and the mean, and then square that. This second formula can be useful. You'll notice that the second part of it here is the mean squared. So sum of values divided by how many there are. That's the mean. And so to find this, it's the sum of the squares divided by the number of data values minus the mean squared. How about standard deviation? Very similar to variance, but remember the variance is the sum of the squares, so it's a squared value, and the standard deviation finds the square root of the variance. Remember, variance is often referred to as s squared, standard deviation is s. So there's our square root of our variance, gives us a value of 3.35 as an average distance from the mean. We'll have a look at the formula book in a minute, but there we can see on this diagram that the average deviation from the mean, there it is, those blue dashed lines. And you're given this in the formula book. So this links with the two different formulae that we used for variation, and the standard deviation you can see is the square root of those.